Hello everyone, welcome back to Fanaticos. In previous video, we have discussed about context compression. In this video, we are going to discuss about RAG evaluation. So without wasting any time, let's begin. So first of all, what is a RAG evaluation? So let's start with a problem. So imagine we ask a chatbot like, a RAG chatbot, what is AI? According to our particular database or dataset, anything it might be. So it gives something like AI is simulation of human intelligence by machines, right? And as an engineers, we don't rely on this answer, right? We'll have several doubts like, is this a response correct or wrong? So fine, let's go with another real world example. Imagine we have a hospital, and if uh, a hospital consists of a trained model with particular hospital datasets, and I'll ask a question like, is medicine of some disease X, maybe anything it might be. Suppose that particular chatbot gives answer like antibiotic. So, okay, it has given the answer, which is good, but what if this is wrong? It could be dangerous, right? So, for overcoming this situation, we'll use RAG evaluation. So, that particular RAG evaluation technique is called as Ragas, Retrieval-Augmented Generation Assessment. So, let's code. It's fine. Let's do one thing. I'll create a folder, app.py. So, this is our main code. So, our particular data which we give to LLM and requirements. So, these requirements are nothing but the particular packages or libraries we need to install. In terminal, we'll do something like git space install space or particular, oh sorry, git space install space or particular library name, right? So instead of this, in this particular requirements.txt, we'll write that library names, and here we'll write our requirements.txt file so that it installs all libraries within a single line of code. I mean, single line of prompt. So as we can see that we have the installation libraries. So first of all, LangChain, we all know it. For installing these particular uh, chat agents like Groq, like that, we need LangChain. So we need to install this core LangChain. So this LangChain community will use for creating documents, right? So this part is the new one, LangChain Hugging Face. So in the previous session, until the previous session, we have created embeddings using Gemini model. So now we are going to use Hugging Face. So why Hugging Face? Because unlike Gemini, this is not going to ask any API key and it is completely free to use. Gemini keeps a cost to us, but it doesn't. So we'll use Hugging Face. And now LangChain Qdrant. So Qdrant is a vector database. So this quadrant is used in production level rack systems because we are going to build a production level rack system right now. So we are going to use quadrant. Previously we have used Fayaz for it. Now we are going to use it. Fayaz is not efficient for huge data sets. I mean huge storage, right? So this can hold. So now LangChain Groq. We know why we will use it. We'll use for chatting with Groq AI model. So this quadrant client. So we'll use this for connecting to this quadrant database. So this quadrant is a database, right? A vector database, right? So like that. Quadrant client. So now sentence transformers. We know this, right? This downloads and runs Hugging Face models, right? And fires CPU. Okay, let's remove this. So Ragas, we have discussed about it, right? So it evaluates our AI model response, Ragas. So now data sets. It can create the data sets. I mean, it can create the data. So we'll use this for creating evaluation data sets. We'll discuss about it, no problem. Pandas. We'll use this for displaying our data sets. So python.env. So we all know this. We'll use this for securing our API keys. PyPDF. So this reads the PDF files and unstructured. So this unstructured is used to load different types of documents like PPTs, uh, uh, PDFs, doc, doc, hmm, like that. So next, tick token. We'll use this for token counting and text splitting support. Okay, we'll discuss about it, no problem. So let's begin. Now let's install these dependencies with space install space dash r space our file name requirements ments. Fine. So we are done with installation and let me pull this .env to this. Yeah, it's good. So now data. We need to give the data. So I took the help of an AI tool and got this data. Artificial intelligence is simulation of human intelligence by machines. Yeah, okay, it's fine. This data is enough for now. So let's go to our app.py and let's start import our libraries. Import OS from .env import load.env, which is used for securing our API keys. So now from LangChain underscore community dot document loaders import text loader, which is used for loading our text document. So now LangChain underscore text splitters mm, import recursive character text splitter, which is used for creating chunks. Now from LangChain Hugging Face. Here we need to import our embeddings, right? Import Hugging Face embeddings. So we are not using Gemini. We are using this model, which provides free embeddings. Gemini takes API credits for it, but it doesn't require any API key. It's better, right? So we'll use this. So let's import our vector database. Quadrant import quadrant vector store. So now we need to import the client, right? Mm, Qdrant underscore client import Qdrant client. Right. So what should we import? We need to import the chat model, right? So let's import Groq from LangChain underscore Groq import chat Groq. Fine. So now we need to import our environment variables, right? So for that, and I'll create a variable called Groq API. Okay, API which is equals to os.get env, and we need to go to our it's useless. So let's copy our Groq API and I mean, sorry, we need to copy the variable name. Yeah, we have got our API key. So now, first of all, we need to load our document, right? So loader, okay, equals to text loader, and we need to give our file name, which is data.text, which is a text file. It's completely fine. So now we have took our document. Now we need to load it. Using this loader, we'll load our document, right? So our document is equals to loader.load our variable. I think it's enough. So let's try printing our okay. Let's try printing our document and let's see the output. So let me clear the terminal and let's run it. So we have got an output. AI is a simulation of human intelligence by machines. Okay, we have got a good output, right? So this is our data. Now next, we need to split the document into chunks, right? So let me remove this print statement and let's start chunking. Text splitter equals to recursive text. Okay, recursive character text splitter. So this is the library which is used for converting into chunks. And here we need to give chunk overlap and chunk oversize. I mean chunk size. So in previous video, I mean in starting video, we have discussed about chunk overlap and chunk size. So if you haven't watched it, kindly have a look. And let me give a small conclusion to it. Chunk size. Chunk size means suppose we have a document like this, and in a particular chunk, chunking means dividing a document into meaningful pieces, right? So in a particular document, a set of characters, I mean only a particular number of characters should be there. Imagine there are 100 characters. If we mix these four sentences, there are 100 characters. So in a chunk, these 100 characters should be there, and here on the 100 characters should be there. Something like that. Chunking means. Got it? So I'll give chunk size as 50, yeah, 50 because our data set is small. So let's move on to chunk overlap. So our chunk overlap equals to, so okay, let me give a small conclusion to chunk overlap also. So imagine we have a data like a small data. Let's take a small data as an example. AI is a technology. So if we make this particular line into chunk, then what if it makes like AI is, and another chunk is a technology? So it's completely meaningless. It's completely meaningless, right? It's not good. So what if I give chunk overlap? Then if we give a set of numbers, I mean, if I give some 20 numbers, so let's count the digits in this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Spaces also counted. So what if I give chunk size as 11? In the next chunk, the first 11 characters will be appended to the first chunk. I mean the previous chunk, preceding chunk. Got it? So this is what chunk overlapping means, which is very useful as we see now, right? Which helps our particular sentence to complete instead of breaking it. So I'll give as 10. It's fine. So this is what chunking. So we have created the chunking procedure, but now let's do chunking. Let's I'll take a variable called chunks, which is equals to text splitter dot split documents. So as we have imported here, so we need to give our document. Okay, we have given our text splitter, right? So now split documents, and here we need to give a document name. So I'll give our document variable. Got it? So this is what our document writes. So let me print this chunks too. Yeah. So these are the chunks, right? So right. Qdrant is a production ready vector database. Groq provides fast interface for open source. So this is right. This is what chunking means. It gives the source and page content. I mean details. So this is what chunking. So the chunking is done. Now what should we do? We need to create the embeddings for it, right? So let me remove this print statement and let's create a variable called embeddings, which is equals to our model Hugging Face. I mean our library Hugging Face embeddings and our model name model underscore name, which is equals to here we need to give our model. So in Hugging Face for creating embeddings, the model is mm, yeah BAAI underscore BGE dash small dash en dash v1.5. Good. Now, as we have created our I mean embeddings, now we need to create our vector database, right? For storing the embeddings. So for using Qdrant, we need to create a local server for it. Don't worry, I'll explain simply, wait. Because it must be running always. So for that, I'll use Docker space run dash p. Mm, yeah, dash p 4050 is to 4050 quadrant dash quadrant because we need quadrant, right? So 4050 is nothing but port number. Anything you can give. I'll give simply 4050. And I mean, it's not working because the Docker is not installed here. Okay, let's avoid complex things for now. Let's do one thing. I'll create locally. I mean, what does this particular quadrant do? It acts as a database, right? It stores our embeddings, right? So we'll create a manual database, but it will be stored in a RAM. So quadrant client. This way we can initialize it memory. So the embeddings, everything will be stored in our system RAM, right? So it's fine. I'll use something like client. It's good. So let's create our vector database, which is equals to Conrad vector store dot from documents. So here comes the main part. We need to give our documents. So we need to use only this variable, just remember it. And for documents, what should we do? We need to give our chunks. Got it? And next, we need to give our embeddings. Embedding equals to our variable embeddings. Make sure that these both variables should not be same for all. Also, we need to give our client. mm, yeah, I think small c is enough. It is equals to our variable clients. So we need to give another variable called collection, which is equals to let's give a name called our rack collection. So let's discuss about this. So think of this collection as a relational table. I mean, think of it as a table for our vectors. Vectors will be stored in an organized manner here. So let's see how many chunks are printed. I mean, how many chunks are there? So print length of chunks. That's completely fine. So let's proceed. So previously I have got an error, guys. So it's showing that rag collection is not created. So we need to create that collection. So for that, I'll use clients dot create collection, and our collection name will be rag collection, and vectors underscore config, which is equals to vector params. So make sure you import this from quadrant underscore client dot models import distance comma vector params. Got it? So now our collection name is rag collection, right? We have initialized it now. So vector config, we are telling about our vector database. I mean, our vector database size should be 384. I means it should only contain uh, 384 embeddings. Got it? Think of like that. So distance equals to distance capital D dot cosine. So this is the core logic of this quadrant. Got it? So it's nothing but this particular line. It compares the both vectors. I mean the vectors from embeddings or data and user query. It combines. I mean it compares both. So let's assume these both are vectors. So this is our data, which is primarily known as V1. I mean, we'll just assume it for better understanding. Got it? And this is our vector 2, right? So this is our query, and this is nothing but our data, right? So now the particular or data, the embeddings will be stored here, right? So here for our query, for this also our embeddings will be created and stored in this particular vector. Now this method distance equals to distance dot cosine measures the nearest vectors. The nearest, as more the nearest vectors, as more there is accuracy, right? The distance between vectors, vector v1 and vector v2 should be very near. If the distance is near, then these are the required embeddings for us. Got it? Required embeddings, and these will be sent to an LLM. These will be sent to an LLM. Yeah, don't worry about my diagrams, please. So the core idea is it identifies the nearest vectors, and those nearest vectors are sent to an LLM. Got it? So now let's print this. Let's print how many chunks are created. Yeah, it's fine. So as we can see that 18 chunks are created. Good. So there are 18 chunks. It's totally good, right? So let me remove this print statement and let's continue. So now let's build the retriever. So our retriever equals to vector underscore store dot as retriever. Uh, I think our vector database variable is this. So let's keep this instead of vector store. And now we need to write a variable called search quartz, which is equals to, I'll give it 3. I'll explain you guys. Mm, wait, I think we need to give something like this, maybe k is to 3. Yeah, it's correct. Good guys. So k is equals to 3. If you guys followed my previous session, you can know about this. So let me explain. So imagine our document data.text. Yeah, let me remove this. Yeah, imagine our document consists of this data. Okay, that's normal. And if we want to search about what is Groq, so here we can get answer like Groq provides fast inference for open source large language models, right? Okay, it's good. But when we ask this, we get a response from Qdrant and Embeddings. If needed, vector databases. Because why? As we can see in ChatGPT, if we ask a question, it gives the particular answer. Okay, it's good. But it also gives some additional information regarding to it. Why? Because of this. Because of this. Right? So k is equals to 3 means it measures extra 3 documents. I mean extra 3 uh, context. It measures extra 3 context. So I told to give response according to this, but it will give about this and this, right? So this is called as mm, normally this is called as top tier retrieval. So let me ask the query. So our query equals to tell me about Groq. So now our documents equals to retriever dot invoke our query. Got it? So now let's print our documents. Good. Oh, okay. We got an output, guys. Starting with Groq provides fast inference for open source. Okay, we hate this output. Let's leave this and let's print in a meaningful way. For doc in documents, print doc dot page content and print. Uh, let's print 50 stars. 50. Yeah, fine. Let's proceed. Let me clear the terminal. Yeah. So as we can see, we have got an output like this. At starting, Groq provides fast inference for open source means it's okay. It's working good, right? So now let's make this more advanced. So let me create an LLM. I mean, let's import it. So our Groq LLM equals to, let's use our chat Groq. So now let's give the model llama dash 3.3 dash 70b dash versatile. So this is a model, Groq model, and now we need to initialize our temperature So I'll set temperature equals to 0.1 because we don't need any fancy responses. And now let's give our API key. So my API key will be Groq API. Yeah, it's totally fine. So we have imported our LLM also. So now we need to create the retrieval QA chain. Don't worry, I'll explain it. So first, let's import this from, okay, LangChain dot chains. Import retrieval QA, right? Mm, underscore classic 5. So we have imported this. So now let's go to bottom and here equals to retrieval QA dot from chain type. Here we need to give our LLM. So my LLM equals to mm, my Groq LLM. And next, and my retriever equals to, yeah, I'll change the variable name, guys. Retrievers, something like this, because mm, retriever equals to retriever may form the confusion, right? And here comes the interesting part. Chain type equals to stuff. So this is the interesting part. So now what is this retrieval QA? This all. So this is nothing but it combines our retriever, which we have retrieved the embeddings and recently we have printed the output, right? It combines that and our LLM. Got it? Now what the hell is this chain type equals to stuff? So it means telling to LangChain how to pass the documents. So this stuff means pass every document to the LangChain. I mean pass every document uh, into LLM. Got it? Which means send every retrieved document into the LLM as context. Got it? This is what stuff means. So next, we have given our query, right? Cool. So now we need to give a response equals to QA underscore chain dot invoke. Mm, yeah. So here, we need to give query colon our variable query because this QA doesn't know where is the query. We need to give. I mean, we need to tell here is the query. Something like that. We need to tell, right? So this is what. Now, to print the answer, print response result. We need to give like this for giving the answer. Got it? So let's print this. Here we got a response, right? So we got this because we didn't remove this for loop. Okay, let's forget about it. And we got an answer. Groq provides instant inference for open source. That's all I know about Groq. If you're looking for more information, I don't have additional benefits. Means it's working well, right? Now, here comes the important part. Ragas. Now, we all know what does Ragas do. It compares our answer and it tells that it is correct or wrong according to our data set, right? So now let's create a context. Context equals to doc dot page content for doc in our documents, right? Which appends our complete document into context, right? In a listed data structure in a perfect order, something like this. Now we need to store our response. So let me cut this print statement. I mean, I'll store this in answer variable. Let me remove this print statement. Yeah, the answer is stored here. So now we need to provide the ground truth. Ground truth equals to, we need to provide it. Suppose we are asking about Groq, right? So this will be our ground truth. So it compares the our answer with the ground truth. So here the Ragas expect data set. So from data sets import data set. Good. So he in this way we can create the data set by using this library. So my variable data set equals to dataset dot from dict. So just remind the method. In this way we can create a particular dataset. So now here we need to give the question first of all, which will be our variable query. So this is the question. We need to provide a context because it should understand these all. In this way, it can understand better. So here we can give context, comma. Here we can give our answer for comparison purpose with ground state. We are telling that this is question, this is context, like that. And we need to give our ground state also. Let's give ground truth. Here the ragas expect the input in this way, in this format. So now our result, which is equals to evaluate. Also make sure that you import your ragas. It should be something like this. From ragas, import, evaluate. So it's done. So no yellow line. So here we need to give our data set. Here I'll add SS for avoiding confusion. So here we need to give metrics. It should be a listed data structure. We need to give conditions like I need faithfulness, answer relevancy. For good output, we need this, right? So let me print the result. I think we need to do this in like this. Then why we got yellow line here? Okay, let's forget about this for some time. Okay, let's forget about this and let's add this here. Okay, I think it worked. Let's give it a try. Mm, yeah, let's copy this from ragas dot metrics. Import. These four should be imported. Yeah, these four should be imported. Fine. Now it's completely fine. And let me print this. Okay. So I updated my code to yeah. First of all, I imported these two packages: LangChain LLM wrapper, LangChain embedding wrapper. So because our Ragas need an LLM, so for that it defaultly takes OpenAI if we didn't guide it. So if we guide it properly, it takes this Groq. So Ragas LLM equals to LangChain LLM wrapper. Our Groq LLM means we are forcing that Ragas to use our Groq. Also, we are wrapping the embeddings into the Ragas. So for this LangChain embedding wrapper, in this we need to pass our embeddings, right? So here in our result, we need to give our LLM, Ragas LLM, and our embeddings, Ragas embeddings. Got it? So as we got faithfulness 1, answer relevancy 0, context precision 1, and context recall 0, right? So this means that answer is perfect. Faithfulness 1 and context precision is 1. The answer relevancy is 0 and context recall is 0, which means our ground truth is not matching, and that's not a problem, but we should have proper analysis according to it. So here we can see we have proper analysis towards our response. So this is the use of Ragas. Got it? So also our answer relevancy is 0. So that's it for today, guys. In this video, we have discussed completely about RAG evaluation. In next video, we are going to discuss about agentic RAG. So see you in the next lecture. Jai.